Find the distance and the midpoint of the given two complex numbers. In this video, we're going to talk about two things. How do you find the distance between two complex numbers? And also how to find the midpoint of the two complex numbers. Now we know that these are complex numbers because the plane that they have given us is a real plane, which is the x-axis is a real axis and the y-axis is the imaginary axis. That stands for imaginary here. So first of all, what we have to do is let's write out what are the coordinates for z1 and z2. So z1, to find the coordinates of z1, we go from the 0, we go to the right first, we have positive 2, and then we go up, we have positive 6. So we have 2 plus 6i. So for 6, it's I because it's on the imaginary axis. And the coordinates for z2 will become, we go to the right first, which is 6, and we go down, which is negative 3. So we have 6 minus 3i. So these are the coordinates of z1 and z2. So first we will find the distance between z1 and z2. There are two ways to do it. Once, if you have a graph, you can just draw a right triangle here and you can just apply the Pythagorean theorem and do it that way. But the second way that I'm going to show you works for all types. Even if they give you a graph or they just give you the z1 and z2 and you don't get to see a graph, you can still apply it in that case. So I'm going to start by that. So we're going to apply the distance formula. The distance formula d is equal to the square root of the difference in the real part, the whole square, okay, plus the difference in the imaginary. The difference in the imaginary. So this is the formula, imaginary squared. So all you have to do is find the difference in the real, the whole squared, plus the difference in the imaginary, the whole squared, and take its square root to find the distance between z1 and z2. In this case, the real parts are, this is 2 is the real and 6 is the real here. So we have to find 2 minus 6 the whole square, that is the difference between the real, and then we have to find the difference between the imaginary. So in this case here, the 6 is the imaginary and the negative 3 is the imaginary coefficient. So we are going to do 6 minus negative 3. Okay, so the whole square, we have to remember to square it. So in the first part we get, in the first question we get square root of first part, 2 minus 6 is negative 4, the whole squared, plus these two negatives become a positive, 6 minus negative 3 becomes 9, the whole squared, because it's 6 plus 3. So we get that as for negative 4 squared, we are also squaring the negative sign, so it becomes 16, and 9 squared becomes 81. So when you add 16 and 81, you get 97. So you can leave your answer as radical 97, or you can get the decimal for this. This is approximately equal to 9.8 something something. You can just calculate that in your calculator. You can leave it like this as the radical. You can simplify the radical if you're able to simplify it. Right now, I don't think 97 can be simplified further, so I just rounded it up to a decimal. So this is how you find the distance between two complex numbers. Now the second part is how do you find the midpoint of two complex numbers? How do you find the midpoint? So that'll be a point, just like z1 and z2, you will get another point. Let's call that m as the midpoint of z1 and z2. So in this first section, we talked about distance. Here we're going to do midpoint. All right. So to find midpoint, all you have to do is you're adding the real. You're going to add the real and divide it by 2 and you're going to add the imaginary coefficients or the imaginary numbers and divide it by 2, imaginary parts and divide it by 2. That's how you get your midpoint. So we have z1 as 2 plus 6i, and we have z2 as 6 minus 3i. So to find the midpoint, what we're going to do is we're going to combine, like add the reals and divide by 2. 2 plus 6 over 2 gives me the real part of the midpoint. So 2 plus 6 is 8, and 8 divided by 2 is 4. So that's my real part of the midpoint. To get the imaginary part, I'm going to add my imaginary and divide it by 2. So 6i minus 3i, and then I'm going to divide that by 2. So 6i minus 3i is just 3i over 2. You can leave it as a fraction, so that's a positive 3i over 2. You can leave it as a fraction, or you can write that as 1.5i as a decimal. It doesn't matter which way you write it. So this is the midpoint of z1 and z2. It says the midpoint is at 4, 1.5i. So if you really want to plot it here, you can from the 0 you go right 4 and then up 1.5, which is somewhere here. So this is where we have just plotted our midpoint, and it does look like the midpoint of z1 and z2. So this is how you find the distance and the midpoint of two complex numbers.